All right, today we're going to be talking about how to use momentum charts to find and solve for whatever the problem's asking you for. So, in this practice sheet, we go through 5 examples that kind of build up towards more challenging problems that you'll encounter. And this will probably be like the last step that you will do in a problem. But let me just do an example for you. Today I'm going to be doing 5 and 6 because 6 is really what a long problem that you'd see on the free response of a test would look like. Okay, so let's do 5 and 6 because they both go together. Okay, so initially, what we're being told here is that we've got a car who's got a momentum of negative 100,000 kilograms times meters per second. Okay, so we already know that it's going to be in the bottom here. So I'm just going to draw a rectangle. Okay, it doesn't really matter what size, but what does matter is that it is beneath the mass axis there. Okay, so when you get that rectangle drawn, we want to label it with as much information as we can. So the problem does tell us that the initial momentum is negative 100,000. So I'm just going to write the negative 100,000 here. And I'm going to run out of space for my units, but that'll be okay. And we're also told that the velocity is negative 20. All right, so there's your 20, and then it says negative direction. So that's another clue that we know that this rectangle goes down here. Okay, so we want to choose the equation. If we want the mass, then we want to choose the equation with an m in it, right? Simple enough. So we go P is equal to mv in the little box I gave you to do your work. And we're going to substitute in our momentum, which is 100,000. Mass, again, we don't know. And I'm going to throw in my velocity here. And then I'm just going to do the division here. And that tells us that the mass is 5,000 kilograms. All right, so there you go. So if you want, you can go back in my key, which I'll post after these are due. You'll see that I do go back and label it. You don't have to, but I did. Okay, so there's question 5. Now, question 6 is a continuation of 5, and it's pretty much like a whole problem that you'd see. Okay, so it says we can use the information from the previous problem, so I'm just going to copy down my momentum rectangle as it looked before. And I'm going to bring along that mass because why not, right? Okay, so something happened to the car. Namely, it hit brakes and then their momentum got halved. Okay, so here's actually a clue that we can use to determine what the momentum of this car was afterwards. Okay, so it's half. Half of negative 100,000 is negative 50,000. Okay. First, we want to figure out what impulse the car experienced. Okay, so here's how you do this. So first up, what this problem wants to know is essentially like what is going on in this chart here. Okay, so that's what you want to think of. Now, in order to figure this out, all you need is to pay attention to this plus and equal sign here. Okay, and I'll show you. What this problem says is negative 100,000 plus something we don't know is equal to negative 50,000. Okay, so when you add and solve for x, here's what happens. When we do that, we get positive 50,000. Okay, so that's the impulse. All right, so whatever happened here with the brakes, we know that the brakes applied this much impulse to the car. Okay, positive 50,000. So after you get to this point, really, The rest of the problem is no different than anything you did in problems 1, 2, 3, 4, and 5. Okay, so I'll show you what I mean. In part B, we just answered part A, by the way. We want to figure out the time if this was the force, right? So since we're dealing with an impulse chart, we know that this rectangle was 25,000 tall because this is the net force column, or rather axis. So we just want to figure out what's the base of this rectangle. Okay, so here we're just going to do area is equal to base times height. We know the area is 50,000. And we know the height, well, the base stays the base, but we also know that the height is 25,000 here. So dividing from both sides, I believe that comes out to 2 seconds. So I'm just going to replace that with 2 seconds. So it is 2 seconds. Sorry, I know that looks like a 25, but it's 2 seconds. Okay, so that's a full momentum problem. All right, so let me know if you have any questions. Hopefully this helps, and you're in charge of doing 1, 2, 3, and 4 for the day. All right, I'll see you later.